Hi, my name is Gregor Noriskin. I'm the CLR Performance PM. I'm responsible for the performance of the Common Language Runtime, which is a core piece or the core piece of the .NET framework. I'm going to talk to you a little bit about profiling managed code. Profiling is a key part of performance optimization. In order to actually make your managed code perform as fast as possible, you really need to understand what your managed code is doing under the covers. Specifically, I'm going to talk about a sample that we've written called the CLR Profiler, which is a tool that allows you to see inside the managed heap and see what's happening over the lifetime of your application. So the first thing I want to talk about is the importance of profiling. If you don't know what's happening inside your application, you really can't begin to understand where you have to do optimizations. Unless you measure the performance characteristics of your application, you don't know what to go and optimize in the case that your application is not meeting its requirements. So what I'm going to show you today is a tool that basically gives you a view inside the managed heap and the garbage collector. And it really allows you to understand at a low level what's happening inside your application. Before I actually show you how to use the CLR Profiler, I just want to point you to some references on MSDN. Most notably, there is a new developer center that is dedicated to the .NET framework. Within this developer center, you'll find resources for writing managed code in general, not just performance. So what I'd like to point out firstly is this article, which is called Writing High Performance Managed Applications, a primer. This is an article written by myself, and I point this out for two reasons. One is because this is where you can actually get at the CLR Profiler source, and two is that this is a good article that introduces the performance discipline in the context of managed code. There are other two articles I'd like to point out to you. One is Writing Faster Managed Code, Know What Things Cost. This is an article written by Jan Gray, who is a CLR performance architect, and this establishes a cost model of various primitive operations in the CLR. This is a very important aspect of writing fast managed applications, is really understanding at the lowest level what the cost of various intrinsic operations in the CLR are. The other article I'd like to point out to you is an article written by Rico Mariani. It is called Garbage Collector Basics and Performance. This is an article that gives a detailed description of what's happening in the garbage collector in the context of the Common Language Runtime. So all three of these articles actually refer to the CLR Profiler and will actually give you a link to the source. So the first thing I'd like to do is actually go and see what happens when you download the source. So actually I have the source here on my desktop. When you download it, you'll see that there are no binaries in this download. It's simply a zip file that contains the source for the CLR Profiler, a CLR Profiler control, which is a managed control, and a profiler object, which is a component required by the profiler, which is written in native code. So the easiest way to build this application is to just run nmake in this directory, and it will generate the CLR Profiler for you. So now let's go and look at the profiler itself. The application that I'm going to profile is a fairly simple application. It's a WinForms application. It has two buttons on it. One button called Fill the Managed Heap with Garbage, the other Don't Fill the Managed Heap with Garbage. And I'm going to use this to demonstrate how you can use the CLR Profiler to see what's going on inside your managed heap and optimize the execution of your application. So let's just take a quick look at the actual code. It's very, very simple code. I have two methods here that are executed when the button is clicked. The first method does a string concatenation 5,000 times. All it's doing is it's concatenating the current date time, the string representation thereof, on the end of a single string. In the second case, we do exactly the same thing, but instead of using a string and using string concatenation, we simply use a string builder and we append exactly the same string on the end. The one thing you'll notice about these two methods is that they yield exactly the same result, which is a string that is the concatenation of all these iterations through the loop. So let's go quickly and run this application. Just building it first. So we execute the first method. This is fill the managed heap with garbage. And we see that it takes 3.35 seconds to execute. Now we're going to do exactly the same thing. We're calling this the second method. It yields exactly the same string, and we'll see that it returns in much less time. So now this gives us an idea that there's probably some significant thing happening under the covers that makes these two functions perform very, very differently. So we're going to use the CLR profiler to take a look inside this application and see what's happening in the managed heap, and see if it's actually, if our performance difference has something to do with the memory management. Great, so let's go and take a look at the CLR profiler. This is the main window of the CLR profiler. First thing we're going to do is go and start our application. So we start the application and we're going to fill the managed heap with garbage. Now one thing to notice here is that it's taking a lot more time to execute. This is one thing you have to keep in mind about the CLR profiler. It uses the CLR profiling API, which is fairly invasive. It is going to change the performance characteristics of your application. Now let's go and execute the second method, and we'll still see that the differences is significant between the two methods. So now that we've profiled the application, let's go and have a look and see what happened inside the managed heap over the lifetime of the app. So there are a number of views available in the CLR profiler. The first one we're going to go and look at is the allocation graph. So what the allocation graph shows you is it shows you effectively which methods called which methods, and so on the right-hand side here, on the left-hand side here, you see all the methods that were called, but what you also see is the total number of allocations that method was responsible for over the lifetime of the application. So the root is obviously all methods called in the application, and there were a total of 504 megabytes of allocations across the lifetime of the application. On the right-hand side, all the way across, we see the actual types that were allocated by all those methods. And what you'll see here is that 99.89% of all the allocations in this application were of type system.string. And we'll see that most of those were caused by string.concat. So this leads us to believe that our first method is the culprit for, well, let's just say string concatenation is the reason why the first method was so much slower than the second. So you can set the granularity here to be able to see greater levels of detail. So here we'll see that we start getting more data as we increase the detail. So one of the other interesting views is the timeline. And the timeline shows us what's happening in the managed heap over the lifetime of the application. So we'll want to increase the granularity a bit here so that we can see what's happening under the covers. So we'll see that there are a lot of garbage collections happening here, approximately 486 garbage collections over the lifetime of the application. Now that application ran for a very short time, so this lends us to believe that we're putting a lot of pressure on the garbage collector. So now what I'm going to do is I'm going to run each method individually, and I'm going to contrast the allocation profile of each method, and we'll see how each method affects the garbage collector. So if we run the first method and then stop the application and then go and look at the allocation graph, we'll see that we see very similar characteristics to the first graph that we saw, but remember that we only ran the single method. So we see that 502 megabytes of stuff was allocated over the lifetime of the application in the managed heap, and we'll see that again 99.92% of that was strings. So this is showing us potentially why there's such a massive difference in the performance of the first method and the second method. So if we actually go and look at the timeline, we will see that in order to yield the single string, we had to do 481 Gen 2 collections, and those are full collections, which are the most expensive collections in the context of the CLR. So we can see that this method is fairly inefficient in its use of the garbage collector and the managed heap because it's so intensive in allocations. So I'd like to just point out another view to you that the CLR profiler provides, and this is the call tree view. And the reason why this is so good is often what you'd like to see is you'd like to see your managed call stacks, and you'd like to see in each frame of the stack what objects were allocated and what assemblies were loaded. So this view shows you your call stacks. So this is our root call stack, and within each frame it actually will show you what types you allocated and what the size of those types were. What it'll also show you is all the assemblies that you loaded. Often you'll instantiate a type and you're not necessarily aware that that type is now side affecting the load of another assembly. This is a good way to actually get a view on what your call stacks are allocating and what assemblies they're loading. So now let's run the second method so we can contrast it with the first. Obviously the performance is much better. If we now go and look at the allocation graph, we'll see that only 2 megabytes are allocated across the lifetime of this application. So that's, the difference is huge. So if we go and look at what portion of that was strings, we see that only 1.6 megabytes of those allocations were strings, and that's really the string that is yielded at the end. So if I'm not mistaken, I think that in the previous function we allocated 520 megs of strings as opposed to 1.6 megabytes of strings. Now let's look what the garbage collector was doing over the lifetime of this run. That's not what I wanted to look at. Let's look at the timeline. We'll see that we actually only required 3 collections in order to clean up the garbage, in order to clean up the managed heap for this function. Now keep in mind that these functions yielded exactly the same string. So what I'm showing here is how you can use the CLR profiler to actually see inside your application and see what the function calls you are making are doing in the context of the managed heap. This is a great way to improve the performance of your application by making sure that you don't gratuitously allocate things and you don't put unnecessary pressure on the garbage collector. So the last thing I'd like to show you is the CLR performance counters. The performance counters are available all the time. You can view them through perfmon, and there are a number of them that relate directly to the CLR. So you'll see if you open perfmon, you'll see that there are a whole bunch of .NET CLR performance counters. Probably the most important one in the context of the CLR profiler and using it in conjunction with performance counters is .NET CLR memory. You'll be able to see how many Gen 0 collections there were, how many Gen 1 collections, how many Gen 2 collections, and probably the most important counter here is percentage time in GC. Typically, in an application that is GC friendly, you're going to see this number somewhere between 10 and 30%. You might see it peak up into 70 or 80%, but its average will be around between 10 and 30%. If you see that there's a sustained percentage time in GC over 50%, you know that you really have a problem. It means that the garbage collector is having to work really hard to clean up the memory associated with your application. There are some types of applications that, just based on the algorithms that they use, have very high allocation rates. But in general, you want to see a lower percentage time in GC. One of the other perf counters you want to look at is these counts of collections. You typically want to see for every 100 Gen 2 collections, you only want to see 1 Gen 0 collection. So if we run our application again, and I'm going to run it in the context of Visual Studio, and we look at our performance counters, we will see that though we're spending a fairly low percentage time in GC, we can see that the ratio of Gen 2 collections to Gen 0 collections is about 2 to 1. So this gives us an idea that there's something happening in the context of our application that is putting pressure on the garbage collector. So the performance counters are what I consider the first line of defense in performance optimization. When your application is not performing, your managed application not performing the way you expect it or the way you require it to, the first thing to go and look at are these performance counters. And the .NET CLR memory performance counters are the way you're going to be able to see if your performance problem is garbage collector related. And a lot of the problems, perhaps 90% of performance problems we see in managed code, relate to misuse of the garbage collector. So, I recommend that you download the CLR profiler and start profiling your applications. Well, hopefully I've impressed upon you how important it is to profile your managed applications so that you can see what's happening inside the garbage collected heap. So I recommend that you go and you read the articles on MSDN relating to managed code performance, download the CLR profiler, and start profiling your applications.